Now here, ready? Our first problem is about the laborer, the number of laborers, and the number of days it takes to finish the job. Here's problem number 4. A laborer can finish a job in 3 days. If there are 2 more laborers who can do the same job at the same rate, join him, they all can finish the job in 1 day. If 1 more laborer with the same rate joins the other 3, how many days or hours would it take them to finish the job? Now let's start. Remember, the problem tells us that if there are more workers, it will take them fewer days to do the job. You can do it this way. What's the first variable? The number of workers. What's the second variable? The second variable will be the number of working days. Let's have first in a table. It says a laborer, 1 laborer, can finish the job in 3 days. So 1 worker, 3 days. Next, if 2 more laborers will join, so 1 plus 2, there are already 3 workers this time, they can finish it in 1 day. The question, if 1 more laborer with the same rate joins the other 3, it means there are already 4 workers this time, then how many days or hours would it take them to finish the job? Now, here's how we do it. Remember, you can just simply multiply it. 1 times 3, so our K is 3. There are 2 ways to solve the problem. Let me show you the first way. The first way is you solve for K, and then you go to your general formula. Y equals K over X. Y here is missing. K is 3 over our X, 4. That's the answer. It will take 3/4 of a day. Or let's do the other one. Ready? This is X sub 1, Y sub 1. X sub 2, Y sub 2. So you have X sub 1 times Y sub 1 is equal to X sub 2 times Y sub 2. X sub 1 is 1. Y sub 1 is 3. Equals X sub 2 is 4. Y sub 2 is missing. So you have 3 equals 4 Y sub 2. Divide both by 4. So Y sub 2, it's not Y squared, Y sub 2 is equal to 3/4 of a day. Same answers, right? It's up to you which procedure you'd like. Now let's go to the next one. In the next one, it tells us that the longer the string is, the less will be the number of vibrations or the rate of vibrations. Now here, the rate of vibration of a string under constant tension varies inversely as the length of the string. This will be R, this will be L. L is just a sign. So we can write our general formula as R equals K over L. If a string 30 cm long vibrates 180 times per second, let's check here. If the length is 30 cm, it will vibrate 180 times. What is the rate of vibration of a string that is 45 cm long? We are looking for the rate of vibration. First step, we can solve for K. K is the product of these two. So 30 times 180 is 5,400. Let me use the first method, okay? It's easier for me. So we'll have R, we are looking for R, was 5,400 over L. This is our equation of variation. Let's substitute 45 to L, the length of the string. So we have R equals 5,400 over 45. You can use your calculators. The answer will be 120 times per second. Please do not forget to write the unit of measure. So, if the string is 45 cm long, it will vibrate 120 times per second. Let's go to the last one. Ready? Now, here's the problem. To balance a seesaw, the heavier object should be placed closer to the fulcrum. It says if the mass is going up, you need to go closer to the fulcrum. While the lighter object, so if your mass is just going down, then your distance can be farther from the fulcrum. Monica and Mario are on a seesaw. Monica weighs 60 kilograms, while Mario weighs 54 kilograms. If Monica is 120 cm away from the fulcrum, then how far should Mario be from the fulcrum to balance the seesaw? Here, the first one is your mass. The second one will be the distance from the fulcrum. So let's solve first for the constant of variation. You multiply the two. 60 times 120. The answer will be 7,200. Let's write our equation of variation. We have y, not y. Distance equals k over m. Now, so we have distance equals 7,200 divided by m. How heavy is Mario? Mario is 54 kilogram in mass. So you have the distance, that's 7,200 over 54. Let's divide. That's 7,200 divided by 54. If your answer is not an exact one, you can write it up to 2 decimal places. It's 133.33. Or you can place a bar on top since it is repeating. So what's the answer? Mario should be 133.33 cm away, the distance away from the fulcrum. Now, any questions?